day to everyone. Today, I would like to present our proposed solutions called Quantum Sustainable Agriculture, which combines quantum computing, 6G communications technologies, and smart agriculture systems to address some of the biggest challenges facing in this modern farming world. Agriculture is the foundations of human survival. However, modern agriculture is facing several critical problems. The first problem is the rapid increase in the global populations. As the population start to grow, the demand for food continue to rise. Farmers are expected to produce more food using limited land and resources. The second problem is the overuse of pesticides and chemical fertilizers. While these chemicals helps to increase crop productions, excessive use causes groundwater contaminations, soil degradations, and environmental pollutions. The third challenge is the climate change. Weather patterns are becoming increasingly unpredictable, making it difficult for farmers to determine the best time for plantings, irrigations, and harvesting. Traditional technologies often struggle to accurately predict these complex environmental changes. To overcome these challenges, we propose the implementations of quantum sustainable agriculture.
Before discussing the solution, let us first explain about quantum computing and the 6G networks. So, what is quantum computing? Quantum computers use qubits, which can exist as both 0 and 1 simultaneously, through a phenomenon called superposition, which are totally different compared to traditional computers that use bits which can only be either 0 or 1. Another important concept of quantum computing is entanglement, where multiple qubits become connected and influence each other regardless of their positions within the system. These unique properties allow quantum computers to process multiple possibilities simultaneously and solve highly complex optimization problems much faster than conventional computers. Alongside quantum computing, we introduced 6G technology, the next generation of wireless communication. 6G is expected to provide data transmission speeds exceeding 1 terabyte per second with nearly zero latency. More importantly, 6G enables real-time communication between billions of devices, sensors, and intelligent systems. In agriculture, 6G acts as the communication bridge connecting sensors in the field with quantum computing systems and farmers.
So now, let us look at how the proposed systems operates. This process begins with thousands of smart sensors deployed throughout the farmland. These sensors continuously monitor soil moistures, nutrients levels, fertilizer concentrations, soil pH, temperatures, humidity, rainfall conditions, and also plant health indicators. All of this information is transmitted through the 6G network to a centralized quantum computing platforms. Quantum computing then analyzes millions of possibilities farming scenarios simultaneously. Using advanced optimized algorithms, it can determine the best planting period, the most suitable crop varieties, the ideal irrigation schedules, the optimal fertilizer usage, and also the most effective pest management strategies. Based on these calculations, farmers receive real-time recommendations that helps maximize crop yield while minimizing environmental impact. One exciting future applications is the development of a quantum controls greenhouse. Imagine growing a tropical fruit in a region experiencing winter conditions. Instead of relying on excessive heatings and energy consumptions, a quantum computer could simulate the exact environmental conditions required by the plant. It could calculate the ideal light spectrum, the precise water required, the correct carbon dioxide concentrations, and also the optimal temperatures and humidity levels. The system could even predict temperature changes before they occur. Through the 6G network, commands are instantly sent to the greenhouse equipment, allowing heaters, irrigation systems, and lighting systems to respond proactively instead of reactively. This creates a highly effective and sustainable growing environment.
Now, I would like to explain one of the challenges of this system, which is sensor noise. Sensor noise happens when the sensor cannot give accurate reading because of the underground environment. This can affect the performance of the system. There are several reasons why this happens. First of all, the soil is not the same everywhere. Different soil type can affect the accuracy of the sensor measurements. Second, air pocket may form around the sensor if it's not installed properly. This can cause incorrect reading. Third, a high amount of salt in the soil can increase electrical conductivity and disturb the sensor data. Lastly, water does not always move through the soil. It may flow through the crack, the root channel, or wormhole, causing sudden change in the sensor reading. Because of this factor, the system may sometimes collect incorrect data, which can affect decision-making in agriculture. Despite these challenges, quantum sustainable agriculture proves many benefits. First, from an environment perspective, it helps reduce the use of fertilizer and pesticide. This can help lower pollution and protect biodiversity. Second, from an economic perspective, farmers can reduce operating costs while increasing crop productivity and yield. This means they can earn more while spending less. Finally, from a social perspective, better agriculture efficiency can improve food security. It also supports sustainable development and help provide enough food for future generations. Overall, quantum sustainable agriculture can make farming more efficient, sustainable, and beneficial for both farmer and environment.
Despite its potential, there are still several limitations. Quantum computers are currently expensive and require specialized infrastructures. The technology is still in its early stages, and many agricultural applications remain under development. In addition, the effectiveness of the system depends heavily on the quality and reliability of sensor data collected from the field.
To sum up everything, we know that quantum sustainable agriculture represents a promising future for modern farming world. By combining the computational power of quantum computing, the connectivity of 6G networks, and the intelligent sensor systems, farmers can make a faster, smarter, and more sustainable decisions. Although challenges still remain there, this technology has the potential to revolutionize agriculture, increase food productions, reduce environmental pollution, and help society to adapt the challenges of climate change. That's all from us. Thank you.